Welcome back to learning program Cisco Networking with Rajput. Today we are going to talk about iBGP files. These are the common questions which I faced a lot of trouble with when I was learning BGP in initial days. The common questions are, can I have iBGP peering on physical interfaces? And the answer is yes, of course we can, but that may create a lot of trouble to our network. Our network may not be that stable. We will have a look at that with the help of one topology diagram, and we will configure the devices. The next question is, why should I have BGP peering on loopback interfaces? Both of these questions are interrelated. So when we see the negative effects of iBGP peering on physical interfaces, those all negative effects will become feature for iBGP peering on loopback interfaces. That is why Cisco recommended to use iBGP peering on loopback interfaces. And the next is, in iBGP we frequently see these two commands: neighbor IP address next of self, neighbor IP address, and update source loopback and loopback interface number. Let us see the scenario we have. We are going to use this design diagram. There are 5 devices and we have these 3 devices: router 1, router 2 and router 3 for iBGP. All these 3 devices will share AS100 and router 4 will share AS400. Router 5 will have AS500. Okay, let us configure iBGP using physical interfaces. Let us start with router 1. Conft router BGP 100 neighbor 2 12.112 remote AS 100 neighbor 13 113 remote AS 100, and let us advertise the network configured on loopback 2. Let us go to router 2. Okay, next neighbor is 12.1.1 23.1.1.2 remote 103 network 22.22.22.22 mask will be 255 255 255. Let us go to router 3. Router BGP 100 neighbor 23.1.1.2 remote AS 100 neighbor 13.1.1.1 remote AS 100 and network will be 33. Mask 255 255 255. Okay. On router 1, let us check. One BGP session is up, another one is also up. So currently router 1 has iBGP session with router 2 and router 3. Let us check on router 2. Again the same on router 3 as well. Okay. Let us check to show iBGP BGP table on router 3 and see what all prefixes it has. It has 11.11 from router 1, 22.22/32 from router 2, and 33.33 it is advertising in BGP. 11.11.11 source loopback 2. Okay, so we can reach 11.11.11.11 sourcing from loopback 2 interface of router 3. Okay, the physical media which is connecting router 1 to router 3 and router 1 to router 2 and router 2 to router 3. It's quite possible that because of any hardware malfunctions and the connectivity between two devices goes down. We will simulate the same situation by shutting down physical interface connecting R1 to R3 on router 1. Let us go to router 1 to show IP integrity and physical interface fast Ethernet 0/1 connects R1 to R3. Let us shut it down. Let us clear iBGP so that we don't require to wait for 3 minutes to BGP to reset neighborship. Okay, router 1's neighborship is down because the physical interface is down, and neighborship with router 2 is up. So let us check the BGP table. Currently, router 3 doesn't have any prefix from router 1. If you have watched my previous video, BGP rule of split horizon, I have explained why iBGP peer doesn't advertise iBGP learned route to another iBGP peer. This is BGP's mechanism to avoid loop within the network, and now R3 doesn't have any way to reach to R1's advertised prefix. On the other hand, if we had iBGP pairing on loopback interfaces, then the physical interface connecting R1 to R2 and R2 to R3. In that case, there will have been IP reachability, and BGP session will not go down in such situation where one physical interface goes down and another one is available. This is the reason Cisco recommended to use iBGP pairing on loopback interfaces, because that will make your network more stable, more scalable. Let us go to the next query. What is significance of commands like a neighbor? And for that, let me remove iBGP pairing which we have created on physical interfaces. For simplicity, I will simply remove complete routing instance on router on all the three routers, and will recreate iBGP pairings. No router BGP 100, no router BGP 100, no router BGP 100. Let us configure some IGP. We will use OSPF. Route OSPF 10. Network is okay, and loopback 1 as well. Let us go to router 2. Router OSPF 10 network. Let us go to router 3. Router OSPF 10 network 23.113. Okay, OSPF never ship up. So with the router 3, OSPF adjacency is in Xstart mode, and with router 1 it's a full. Okay, for R3 as well, it's up now. Okay, let us see to show IP route. OSPF only. To ping source loopback 1. Yes, we can. To ping source loopback 1. We can. Okay, let us we have IGP reachability on loopback 1 interfaces. So we will use these loopback 1 interfaces as sources of iBGP, and let us configure router BGP neighbor 2.2.2 remote is 100. Neighbor 3.3.3 remote 100 and update source loopback 1. Neighbor remote 100 and update source loopback 1 neighbor. Okay. Router BGP 100 neighbor remote AS 100 update source loopback 1 neighbor 2.2.2 remote 100. Okay, BGP is up now on router 2 as well, on router 3 as well. Okay, let us configure router 4 and 5. Router BGP 400 neighbor is 14.1.1. Remote AS 100 network mask will be /32. On router 5, router BGP 500 remote AS 100 network will be 555. So /32 again. Let us configure router 1 and router 2 as well to have eBGP peering with router 4 and router 5 respectively. Neighbor 14.1.4 remote AS is 400. On router 2 neighbor 25.1.15 remote AS 500. Okay. On router 1 we see all the 3 neighborships are up, 2 iBGP and 1 eBGP with router 4. And from router 4 we are learning one prefix. Router 2 as well, it's learning one prefix from router 1, 3, nothing, and 25, it's learning one prefix. Let us check router 3 as well. Router 3 has two iBGP sessions with router 1, and router 2, it has got two prefixes learned from router 1 and router 2 to show iPBGP. So answer to the first question, neighbor IP next of self. Why do we use neighbor IP next of self command in iBGP? This is the reason. See, the default behavior of BGP is eBGP will always reset the next hop and it will set its own IP address as the next hop IP address. But in the case of iBGP, next hop IP is never changed. Next hop will always remain what eBGP has set. So in this case, router 3 has router 3 has next hop as 25.115 to show IP route. Let us check if it has routing for that or not. This subnet is not there in the routing table of router 3. That is why both of these prefixes, let us check for 14.114 as well. No, it's also not there in the routing table. So whenever there is a situation when the subnet which is configured between two devices on which we have configured eBGP, if this subnet is not advertised in BGP, then we always require to set the next hop IP address on the receiving end iBGP peer. Because what will happen when we issue the command router 1 to set its own next hop IP address, then it will remove the next hop IP address received in eBGP and set its own next hop IP address and advertise it in the iBGP domain. So the complete iBGP domain knows how to reach to the R1. That's how the next hop reachability and the prefixes will be installed as best routes. Let us configure next hop self on router 1 and see what is the effect. On neighbor 3, I'm setting next hop self. Let us go and check on router 3. So we set next hop self on router 1 and router 1 has reset its own next hop as the next hop IP address in the update. Earlier it was 14.1.1.4 which eBGP has set, but now we enabled iBGP to reset next hop IP address from what eBGP has configured to its own IP address. So as soon as the IP address, next hop IP address is changed to 1.1.1, this device must know how to reach this IP address, and that's why it's getting it OSPF 10, and that's why this prefix is installed as best route in the BGP table as well as in routing table. So if we go and set the next hop self command on router 2, then we must see this prefix as well as the best route. Let us go and do that. Okay, one more thing. Uh, we on router 1 we set next hop self only for router 3. Let us see how router 2 reacts to the update which it got from router 1. Router 2 is not installing 4.4.4.4/32 because it doesn't know how to reach next hop to show IP route. It doesn't know. Okay, let us configure for R2 as well. Neighbor 2.2 next hop self. and on router 2 as well to show section router BGP neighbor 1.1.1 next hop self neighbor 3.3.3 next hop self. Okay, on let us check on router 3 to show IP BGP. Now both the prefixes are best. So this is the significance of command next hop self. Okay, so next query was significance of command neighbor IP address, update source, loopback. By default, it's a BGP's behavior that it will take the physical interface as the source and it will try to negotiate and try to establish a BGP session with other end. But whenever we are trying to have uh, iBGP peering on loopback interfaces, then we must specifically mention that we want loopback interfaces to be the source of the BGP session. That is why in all the cases where we use iBGP on loopback interfaces, we must specifically tell BGP that you need to source your session on this specific interface. iBGP session will never come up because that will always try to source from the physical interface, and on the other end the configured neighbor IP address is loopback IP address. So both of these will differ and iBGP session will never come up. If you find my videos informative, please don't forget to like, share and subscribe. Thank you for watching. Hope to see you again.